Okay, let's go ahead and get started. I know this session is keeping you from lunch, so it's especially important for us to get going here. So my name is Ryan Hodgen. I'm an architect, solution architect with IBM. Been an IBMer for 15 years, and over that time I've worked with a variety of development and architectural roles. Now I'm the lead solution architect for our healthcare and life sciences team that exists in the Watson Cloud platform. And what I do is I work with our healthcare clients as they try to make the shift from what they've been doing traditionally onto the cloud. And so that means some cloud native transformation. It means understanding different ways of building their applications, but always from a security perspective. And in healthcare, regulatory compliance is such a key aspect. The first question I get is it HIPAA ready? And so when I saw the partnership between Lightband and IBM, and was excited about that. So I've been a fan of reactive architecture for a long time. And to explore what does this mean for a healthcare client? How could they be actually adopting the reactive architecture, but in a way that allows them to maintain that regulatory compliance. So one thing I'll mention is that here on the slide, I see a link to the SlideShare site, and there I've already posted the slides for this talk. If you want to download those, feel free, and we can follow along. Okay, so security. Security is a kind of top-of-mind issue right now. If you're familiar with an event that happened real recently, a company called Equifax that just, a small company that manages a whole bunch of important information about us, right? It has credit card data, social security numbers, it has addresses, lots of personal information about you, and it was hacked. Hacked in a very visible way with all of this data being exposed. 143 million people in the US, with people in Canada and the UK as well having their data exposed, and really kind of highlighting how dangerous these hacks can be, exposing a lot of personal information and sensitive personal information with the consequences that can come from that. And this has gotten quite a few companies talking about what is our security posture. And if you look at the fallout from Equifax, what happened there, we have a drop in stock value. Immediately when this is announced, the stock tanks. You have lawsuits that are pending. There's estimated to be $5 billion of pending lawsuits that could be sent across to Equifax. You have executives who have resigned. You'd expect a CISO, maybe in this case, maybe the CIO, but all the way up to the CEO in the case of Equifax. So a major fallout from this incident. And then fines that are being levied from government agencies. Now, this happened before the new regulatory compliance that will come out of Europe called GDPR, but that compliance standard has a requirement of 4% of annual turnover. Now that's the maximum fine you can issue, and for a case like this where so much data leaking, probably would be the maximum fine. And in the case of Equifax, that'd be $125 million that they'd be spending just as a fine for this issue. And this is enough to make some executives really want to sell some stock. What was the root cause? How did this happen? Well, the vulnerability really was a result of struts. That they had an application that was built on Apache struts that failed to include a patch that had been released. The patch was something that identified in March of this year. The patch was immediately available. The team felt like they were going to patch it. They tried to make an attempt to do it, but failed to actually patch it. And in the course of the time from March to May, when they feel like they were first breached, to the time of July, when they actually resolved the issue, that's where you have the data of 143 million people, plus multiple incidents where they've established web proxies to be able to get more data, and basically had a run of amok within Equifax. All of this happened over the course of that period, really because a result of failing to patch a vulnerability there. And this gives a personal impact that for those individuals, 143 million of them, and I am one of them. You can see the message that Equifax gave to me. My first reaction is, no, Equifax, thank you. That my personal data is now exposed and is available. So far, they haven't seen it show up on the dark web, but it's certainly possible it could in the future, with the risk of identity theft and possible financial implications for people who have this exposed. And so with consequences like this, they're pretty serious, but they can actually be worse. I don't know if you saw this announcement, but this is the case where Abbott, which makes Pacemaker, had to recall 500,000 pacemakers due to fears of patient death. That's a pretty serious issue. obviously, and one that you may not think about, that even a pacemaker could be hacked. But in this case, this isn't such a simple fix that you patch a jar file and you ship it into an application and post it on your web server. In this case, each individual that has this pacemaker has to go to a doctor's office and have it patched. So the stakes keep going up and up as we have software-based systems, and software being everywhere means that security has to be top of mind. So this leads to extreme risk aversion, that we have organizations that are so fearful of having an incident like this happen that they become really restrictive to the point of not introducing new technology, not looking at how they can innovate, not being able to embrace what's happening in the market, and risk actually becoming left behind by their competitors because they're failing to actually innovate. And so that's something that we want to be cognizant of as well. We don't want to be too far on the risk side. We need to be able to incorporate new things, but in a secure way. So then looking at the history of where we've come, let's take an example of a monolith that's here. So if you were building an application maybe 10 years ago, this is what it would likely look like. And in the case of healthcare here, we'll use an example. This is an application that's gathering patient vital information. Okay, so it's posted, we have these different aspects of it. It's following the MVC pattern, which is model, view, controller. We have the model, which are the entities that represent the data that we're storing and really the things that we're capturing. So we have our heart rate, respiratory rate, the blood pressure, and then information about the patient. Those are all attached to the patient there. We have the controller, which is the business logic behind the system. It's actually doing the work, maybe receiving the event of we've recorded these vitals now and we need to process the data. Maybe there's a risk that's in place there that we need to now send a notification or an alert out to somebody who's managing that patient or is responsible for them to make them aware that this is happening. And then we have the view, or the rendering of the data, so you can visually see it. Right? And so here we have a JSP that's giving you a report of those patient's vital information. Now, what's nice about this is that it's packaged in one unit, which actually can be kind of convenient, that you have it all encapsulated into one single ear file in this case. You can deploy it to a web server. You can secure it, harden it, kind of monitor it as one specific unit. And this is how operated for quite a while. But then there's some downsides to it too. That if you have this unit, now all of a sudden you don't have the ability to make changes. You need to increase the number of instances of the system that's processing those vital signs. You need to deploy another instance of the entire application all over again. And that means that you don't have the same level of scalability. You can't be able to grow that application as you might like to. And also then you don't have the opportunity to be able to innovate, to create new features without impacting the rest. It may be that patient vitals piece is so important that introducing a change into it could have such an amount of risk that you fail to do anything in the system and just leave it as is, out of fear. So then if we decide to apply reactive patterns here, what does it look like? When we break these things up into different services, we can see we still have the receipt of the vital information. We're receiving that data. We are able to process it and then maybe break it up into different subcomponents that handle the different aspects. They're able to trigger alerts or as events if they need to. We see that the patient information is stored separately. And then we can still view a rendering of the data of the patient and the vital report there. And so we've been able to separate these things. Now we have the flexibility to be able to introduce new changes. You can create a new version of, maybe it's the heart rate monitoring, that there's some new features you can incorporate or some new metrics that you can track. You can deploy that separately without taking down the entire system or trying to modify everything else. You can also break it out between teams and have the opportunity to be able to have a team really focus on one individual area. And this really is a driving principle behind microservices in general, but one that you can see has some benefits. The downside is now you have to manage all these things. You have to keep track of them. Are they healthy? What should be allowed to actually interact with each other? Maybe there's some controls that should be in place. So you've taken something that was pretty easy to harden and secure, and now you've made something that is a little bit more difficult. So in the view of a compliance officer, it might be something like this, where you've had something on the left there that was scary, but at least it was one thing that was scary, and you could manage it, you can control it. And you've taken that, and now all of a sudden you have many different things that you have to control, you have to keep a track of. And if your organization struggled to be able to manage that single unit, how are you going to be able to manage tens or hundreds of those things? And that becomes pretty scary. This is an image I first saw the Uber team use, and I think it illustrates it well, that transition that, in the view of some people, may not be so easy to handle. And what you see here is the developers see themselves as superheroes, right? They're able to introduce new things rapidly, they're innovating, they're able to accomplish things, bring the business up to a whole different plane, and then you have compliance officers who are pretty nervous about these developers, that they may be introducing stuff that then puts them at risk, that then all of a sudden has exposed the organization to something that would end up being like Equifax, and that's a pretty scary thing. So if we go to the patterns that make up reactive, can this help us? Can this actually help improve the situation that we're in? And if we go to, there's two main patterns that you see come up all the time when it comes to reactive. The first one is event sourcing, right? Being able to capture the events in your system and apply that to a log to have traceability to what happened throughout its lifetime. That you get the opportunity to capture the state in a way that is immutable, that you can then kind of track it through the history. And Martin Fowler kind of defines it as a sequence of events here, capturing all changes to an application state as a sequence of events. And he uses the apt analogy of source control, which developers all understand so well. GitHub really is an event sourcing system. You have the changes that are made to the system, and then you have be able to snapshot and recover and be able to integrate changes. That really is a good example of event sourcing. And then if you're talking to a business person, you can talk about it being a ledger, which if you think of just your bank, you have the ability to have transactions happen, but you're not modifying the old transactions, you're just adding to them. Some of the motivations here, obviously you have the ability to distribute these events now, that it enables this distributed world that you may not have been able to have before when we had a non-event source system or transactional-based system. You have this full visibility of the history. If you had an incident where the system went down, you could still replay the events to get up to the point where you were at when that crash happened. So you have the speed to recovery. And then you have a natural audit log. And this is something that's appealing to a compliance team, that you would be able to have that full visibility to what happened over the course of this application's life. So let's take an example and talk through this here. We have our malicious actor. And our actor in this case is Ferris Bueller. I don't know if you've seen the movies Ferris Bueller before, but this is the part of the movie where he's about to try to get out of school for the day. Right? And so he's calling in, faking that he is parents, and then trying to get out of school. So what happens is that the principal's watching the screen as he's talking to Ferris Bueller's mom and telling her that Ferris has been gone for 9 days a year. And while he's watching the screen, the numbers of days absent moves from 9 down to 2. And you can just see the look in his eyes of what is happening here. Such a scary thing that he's witnessing. How do you recover from that situation? You know the days absent should be 9. Now you see it's 2. Something's wrong. How do you recover? Well, probably you're going back to the application logs. What happened? What was the code that executed? Do we have traceability here? And you may or may not ever come up with an answer. It's possible those application logs were wiped. It's possible that portion of the code wasn't logged for some reason, and you're yelling at the developer responsible for that. But you may not have the traceability to be able to recover from that incident. In the case of event sourcing, what you would look at this as is a series of events that have happened. Right, that you can go back in history and see, well, Ferris Bueller at the beginning of the year, in January, he had 5 days absent, and that was incremented up over the course of the year. Then all of a sudden in May, it dropped down to 2. That doesn't seem right. Something happened there that isn't correct. And that would give you the opportunity then to remove the event that's incorrect and be able to take the system back to its right state. So one comment I'll make on this, though, is around an upcoming regulation called GDPR. I mentioned it earlier, the General Data Protection Regulation. This is coming from the EU. And an aspect of this one that's worth being aware of is the right to erasure. And it's important to be aware of this one anyway, but especially this topic. The right to erasure means that a European citizen can request that you remove their data from the system. If you have anything identifying them, they can say, remove that. The challenge with that in event sourcing is that you have this mutable log that you've made these entries. Do you go back in the event source history and remove them? When the compliance posture says that you would need to be able to wipe all data that you have, including from backups of that individual. And if you're treating your event source as backup data, does that mean that you have to remove it? And so I brought this up with various people and gotten different answers. But one thought and one thing that keeps coming up is that maybe you just use identifiers for the individual and have the information stored separately and then be able to wipe that. But this is an interesting issue that's coming up, and there'll be quite a few with GDPR, so this isn't the only one. But this one hits in event sourcing kind of directly on. Okay, so the other pattern that we have is called CQRS, right? And this is Command Query Responsibility Segregation. And this one simply is being able to separate your reads from your writes of the data. If you are normally processing something, you might have the opportunity to do both at the same time. Our monolith we looked at there had these entities that represented them in the model, represented the database. And in that case, you could modify those as you needed to and then just persist them to the database. That means that you're doing probably a create, you're doing an update, maybe a delete, and you're doing the read of the data as well. So the whole CRUD. But in the case of command query segregation, or CQRS, in that case what you do is you allow for the creation of the data, and then separately you have a separate model for the read of the data. Now, the way that I think about this is that the use cases you have for those two might actually be different. You might have a situation where you record the birth date of that individual, but then the person who's reading it, say it's a bartender at the bar here in Austin, they don't actually need to know that person, or what that person's birth date is. But they need to know that person is over the age of 21, because the law says that you have to be over 21 to drink. So in that case, that service can just pull in the information of the age is over 21 without having to capture the full birth date, which then introduces some issues there. And that enables the principle of least privilege, which comes up repeatedly around compliance and being able to get just what you need to perform that aspect of the function. And some of the motivations beyond that one, you can support the different displays. You might have the opportunity to render it differently because of the model construct. It fits really well with the bounded contexts of domain-driven design, the DDD. And that whole pattern, that area of DDD fits well with that. And then it supports, which I think is really interesting, different access control rules you can have around that data. That you likely don't need the system that's writing the data to have full access to read the data, unless, especially in this model, we have these microservices that are established. You likely want to have some difference there. And that gives the opportunity to apply some rules around what can write the data, what can read the data, what are the contexts that can do that in, and then have more auditability and traceability around that. So coming back to our example of Ferris Bueller's Day Off. So we have the principal here who may or may not need to be able to update the days absent. You may have an admin in the office who can be able to create a new one, but then the ability to change it or decrement it, that could be something that is more controlled. Or the rendering, you could separate the view of the data, like in the screen he sees here that allows him to see the days absent. You could separate that completely from the code that's actually updating that data to then put some more controls in place and some more audit to say, this happened in decrementing the days absent, but here's the log that showed that it was necessary in this case with some of that traceability in place. And with the goal of then locking Ferris out and keeping him from actually modifying his record, his days absent. Okay, so I want to talk through this a little bit more in some more detail, and the stack that I'm going to be using here is something that we see coming up in IBM and see something as a kind of an exciting combination of things here. We have Docker containers, which, who here uses Docker? most of the room. And what we see here is really the use of the registry function, being able to store containers, and the image aspect, being able to capture that container image and have it be a deployable unit. So you have the construction of the application plus its dependencies to make this one deployable unit in the container. And then Kubernetes. Kubernetes as the orchestration layer, and there are others here too, but Kubernetes is we're seeing a lot of community excitement. There's a lot of work that's happening, a lot of new features being introduced, and something that we have supported and contributed to as well. In the case of Kubernetes, then you have the orchestration layer where it's pulling in that Docker image, it's scheduling it to the worker nodes that should run it, and then giving some visibility to the health and the execution of that container when it becomes a pod in Kubernetes. And then the next layer is one that you may not have heard of. Who has heard of Istio? Okay, has anybody used Istio yet? A couple, good. So Istio is a project that I'll talk a little bit more about since that's the newest part of this here. And it has the service mesh capabilities that allow you to do some more controls and some functionality there. And then the last piece here is the Reactive platform, right? And this incorporates much of the Lightbend technology. This has Lagom, Akka, Play, all kind of packaged together nicely. And then, so we're going from the container level all the way up to our Reactive application. So Istio, a little bit about Istio. This is an open source project that IBM has been working on along with Google and Lyft. And this helps bring about the service mesh pattern, the capability to be able to introduce controls, visibility, some good functionalities. Like here I mentioned some of the features, being able to manage the traffic both into the services and between services. Being able to observe what's happening in that traffic. What are the response codes that are coming? What are the response times that you're seeing between them? And then enabling some policy enforcement to be able to set rules of how those services can talk to each other, how outside systems can talk to the services, and enforce those policies. And also then be able to report on them, to have visibility to what those policies are in a way that you can render it and have some recognition that things haven't changed, or if things have changed, then be able to report on that as well. And the last one is on service identity and security. And this one is interesting in kind of a growing acknowledgement that our services need to have an identity too. That we, in the past, have opened up the internal communication of our systems to allow service-to-service calls with whatever credential you create for them. But that may not be reported. You may not understand what's happening in those service-to-service calls. But in the case of some of these hacks that we've seen happen more recently, we need to have some visibility to this service has an identity, and this service made a call to another service that confirmed that identity, to have more of that traceability to what's happening in the system. Comment on Istio that it has initial support for Kubernetes as well as Consul and Eureka. And then there's planned support for Mesos, Cloud Foundry, and then in the future VMs as well. So you can have virtual machines that are participating in the service mesh as well. Okay, and a quick comment before we move on from the slide is that this slide demonstrates the architecture and the way that it runs in Kubernetes, where you have the service, which is there in green, and then a sidecar container, which is the Envoy piece, and that's the proxy that comes from Lyft, and that Lyft contributed that, which is a high-performance proxy written in C++. That becomes a sidecar container that runs in the pod with your normal service container. And when that's in place, then it takes over the control of the traffic coming in, the ingress traffic, as well as traffic going out, the egress traffic, and then applies rules around that and gives you metrics and visibility to it. So that's how it operates. From a security standpoint, this enables you to do some pretty cool things. I don't know, how many of you have tried to create a trust store before? Add certificates to a trust store and maintain that trust store. It's a pretty painful process. Even with tools that's supposed to make it easier, it's still not something that a developer wants to sign up for. In this case, the way that it works is that you deploy the service just as you would. It doesn't have to have knowledge of the certificates that are there. And then Envoy is running there. What happens is that Istio includes with it a CA, a certificate authority, and it issues certificates out to Envoy, to those instances that are there, and can implement things like mutual TLS between the services. So there's an identity on one service, on service A, and there's an identity on service B, and they have a trusted relationship, so they can actually talk to each other over an encrypted channel. So the traffic that's flowing over the wire is encrypted, and you have visibility to that call that happened. And this uses an emerging standard called SPIFFE, that is the aspect of giving a service identity or an identity to a service. Okay, so some disclaimers about this stack that I will acknowledge that it's not fully production ready. The Istio is at its .2 level. It's going to be at the .3 level in December. That's when the first production version is planned. But the reason I want to introduce it here is so you're aware of what's happening. I think this is a pretty exciting set of a combination of tools. And I think you'll see these be built out more to have better integration and better support so that it's a more cohesive deployment and really easy to get started. The other thing I will mention is that other aspects of security still matter a lot. That you still need all the perimeter security. You need the edge security that is so commonly deployed. It doesn't go away. But what we've seen is that itself is not good enough. In the case of the Equifax hack, that was not good enough. They breached the edge security and then opened a whole bunch of different holes in it to allow traffic in and then allow data to flow out. So you need some more security in place beyond that. Also, database security. If you're storing these events, so an event sourcing model, this becomes especially important. Those events are your audit trail. You have to protect those with a lot of visibility to make sure that those really are healthy. If those get modified, that becomes really dangerous to the system. Also, access management. You still have to have controls of who can do what in the system. You need to have visibility to those admins, what they're doing, making sure that you have that full traceability there as well. And then the one that nobody likes to talk about is policies and procedures. It's the most boring part of all the compliance. But it's really important still. You have to be able to identify, these are the things that we're going to do, these are the steps that we follow, and then document that, yes, we actually follow them. And be able to make sure that that's happening. When it's automation, that's great, but there are some cases where it can't be automated and it has to be issued there as well. And I'll also mention different variations by industry. I mentioned my focus is healthcare, but there are other industries that have different ways of interpreting some of the requirements and different requirements that they have to meet in the first place. And then organizations can interpret things differently and approach things a little bit differently too. But what's nice is there's becoming more and more agreement around the NIST cybersecurity framework. This is becoming more widely adopted by teams, really cross-industry. And what NIST has done is really identified 5 key categories to be aware of in securing your systems. And we'll talk about those in a little more detail, but I'm seeing this become more widely adopted really by teams in very different industries, but then what they do is they add some customizations then to their specific industry to maybe focus on different aspects of it. But we'll use this as kind of the framework for what we talk through with our reactive system to identify some ways that maybe we could reduce risk in our system because of them. Okay, so let's start with identify. And identify, this area is something where you want to be aware of what you actually have in your system. Now, may have visibility to the number of applications that you have. And it's probably a pretty scary number if you're a large organization. But you probably then don't know all the dependencies those applications can have. And this gets more difficult when you say you need to know all of the say jar file dependencies, plus then in your container image that you're using, if you're using containers, what are all of its dependencies? What's that base image you're building from? Are all of those dependencies at risk for a possible incident that could happen? And so you need to identify, first of all, what you have and kind of classify it from an application perspective, but then also from a data perspective. What are the data? What's the data that you're capturing, that you're storing? When is it necessary for you to have? Is it something that you actually is kind of poisonous for you to have and you can get rid of it? You can have some understanding about what you have in place and then understand the risk around that. Right? In the case of Equifax, the data that they had was very sensitive data. And that's something that then you want to give a great deal of control and security around. And then in the case of the applications that have access to that data, that's another situation where you want to have some extra security in place because they're touching something that is so sensitive. You want to secure events throughout the lifecycle, and I'd like to thank Sean Walsh, who helped me get some of the things that he would recommend from the Lightbend team, what he would suggest included here. So he mentioned some of these here, and securing the events is one that he really highlighted, that it's important to have throughout the life cycle, from whether it's generated in a command and then written to the log, whether it's sent on a queue or onto a topic and then published out to the world, you have to have strong security around these events throughout the life cycle. And then I mentioned the storage of it as well, but you want strong confidence that that full pipeline of the event's life cycle is something that's highly secured. You want the ability to route messages well, and especially sensitive messages, that the number of consumers that have access to that, you want that to be as narrow as possible and then have restrictions around that. And then a piece that I'll mention is being able to add tags or labels to your assets to then give you some more traceability and some more reporting capabilities that you may want to be able to build a report of all of my applications that touch sensitive data. If you can pull that report more quickly and then be able to show that, that's something that then you can include in some of the analytics work and stuff that you can do in the future in building more automation. So the next topic is protection. If you identify these things that are important to you, that are critical parts of your application, how do you protect those things to make sure that they can't be compromised, or if they are compromised, and we'll kind of get to detecting that next. But protection. So first of all, encryption comes up all the time. You have encryption that's flowing over the wire, so that network traffic encryption, but then the data at rest encryption as well. And so within the Lightbend suite, you have TLS, SSL support across all the products, and something that can be established. You also have disabling the serializer, which is something, because of the vulnerabilities there, it's been recommended since the 2.4.11 release. And then I'll mention in the case of containers that you want to be able to add some restrictions around what those containers can do as well, that you can minimize the privileges that containers have as they're running to make sure that if there is an incident where those containers are compromised and they try to break out of the container out into the engine and get to the kernel, that you can control what they can actually do if they escape. Now I'll mention using the role-based access control within Kubernetes. That's something that's been went to GA real recently, but has been in beta for a while. If you can add these controls around the admins, what they can do, you can have more visibility to what's happening, record those events, and make that something that becomes part of the audit log as well. And then lastly, I mentioned the security identity piece that we mentioned, of giving an actual identity to your services and then being able to set control rules in place on what those services can do. That's another way to protect systems. And I know this isn't a full list, that there's the opportunity to add more, so if you have ideas or want to suggest other ones, I certainly would like to add to it and have this more as an ongoing list. Next area is detection. So what are you doing to detect an event has happened? Right? In the case of the Equifax hack, you had this incident where it was compromise was found in the struts since it was exploited, and then over the period of months, there was continual pull of data from the system and an expansion of what they're doing internally in the network. It wasn't until July that it was actually detected. Right? So that's a pretty long period from May to July where all this activity is happening internally without detection. Well, hopefully you can build some systems in place to be able to detect things more quickly. So using tracing is a good example of that. We have Lightbend telemetry. I've been talking with that team. Its code name is Cinnamon. And the support they have for open tracing, integrating those traces into other systems. There's Jaeger that comes from Uber, Zipkin, which I think has its origins in Twitter. But being able to then view what's happening in the system. And that's something that comes up all the time with reactive systems. As you have this concurrency that's occurring, you have this work that's happening really in the background without visibility to it. How do you know what's happening? It's getting more of that information, making it visible, that's easy to understand, makes it possible to understand that. Using monitors and alerts, so obviously there's ops clarity monitors, there are monitors that are built in some the other tools. Prometheus is a kind of open source example where it captures metrics and then can integrate with Grafana or other ways to visualize the data and be able to issue alerts to you. One thing that Sean recommended was the Akka supervisors, which in the case of exceptions that are coming from Akka, capturing all of those and then handling them, being able to track the patterns, what is happening internally, getting visibility to all the exceptions, and having supervisors kind of manage that. Another thing I'll mention is around, as we decentralize these systems, we have them dynamically scale, we have them handling all of these workloads and being able to have this cloud-native architecture, you still want to have a centralized view of that. And so even if you have decentralized systems, have centralized logs and be able to make sense of what's happening across this large-scale system. And that gives you the opportunity to integrate machine learning, AI, and be able to detect patterns of what is a normal day, have a baseline for that, and what's abnormal, what's something that has become an incident, that there's something that's not right that's going on. If you see the transfer of gigabytes of data over your network when you normally wouldn't have that, are you detecting it? So the next one is respond. Can you respond to an event if it does happen? You've detected it, you know that there's an issue here, what are the next steps that you take? And in some cases, there's plans that are written out in advance. There's scenario planning that people do, and they talk about, if we have a breach like this, here's what we're going to do. But then there's the famous quote by Mike Tyson that everybody has a plan until they get punched in the mouth, right? So when you get punched in the mouth, what do? Well, in the case of responding, you can say it's a DDoS attack. It might just be that you scale up and you handle it. You might have a design in your application where you say, bring it on, let's scale up and let's handle it. Or you may have an incident where you need to actually isolate the server. You need to put it in quarantine just to avoid the issues that can happen from that. You can utilize circuit breaking and rate limiting to then put some of these controls in place and give you visibility to keeping that service healthy despite an event. And next one is being able to patch rapidly. In the case of the container world, we don't really patch in the same way as we used to, where you would introduce a new jar file and deploy it on the application server. In this case, we're actually building a new container image, and we're deploying that as a new instance, and then switching the traffic over. But if you have the opportunity to make that process very quick and easy to do, that allows you to respond immediately when a vulnerability is announced, because the longer you wait, the more likely it is that it'll be exploited. And then the next one is recovering. Can you recover if there is an incident? That if you responded to it, you've addressed it, but now you have to recover, and maybe it's taken down part of your system, how do you recover from that? So hopefully you have resiliency as part of the application. That's one of the key aspects of a reactive system, is that resiliency piece. Maybe you have that and you can be able to restore it quickly. And if you're using event sourcing, you likely have the opportunity to replay those events. So you have a snapshot that makes that easier to do than starting from the beginning of time. And that's something you've tested. You hopefully have the ability to be able to replicate the data, the event source. So if you have to stand it up in another data center, another region in the cloud, that you can do that easily. And Lightbend has the multi-data center capability with hot backup that's available. And in the case of Kubernetes, there's the ability to have distributed clusters that may exist across availability zones or cross region, and some of that functionality is being built out to and extended to have more capabilities there too. But it's really about being able to recover quickly. Okay, so I'd like to do a quick demo here, highlighting some of the features and really around Istio, but we'll continue on with our example that we've talked about and the incident. I'll mention that I have a kind of a broader demo of Istio with Reactive at the IBM booth. It's back in the area. If you want to talk about it more, I can show you more what's happening and explain how that all works. But okay, so here we'll go to our demo. So we have our application. It's that vitals report application I talked about earlier. It's capturing vital signs from that individual. So it's things like the heart rate, and it's being able to report that into a report that then can be used. And it's services-based, so it's returning JSON data. Okay, and so we have it running in our cluster. We have a 3-node cluster. We have our application deployed, and here's a quick little page for the app. So this application is something that we have individuals use, and we got a report. A guy's sister called in and said that her brother is faking being sick, and he's trying to get out of school for the day. So we need to try to respond to that and figure out what's happened, because evidently he's making it seem like he's sicker than he actually is. So here what we have here, let's see if you can see a better view of it. Okay, so we have what we would see as a vital sign report that actually looks good, right? So we're reporting on this individual, Mary, and these are good signs coming back. We see a normal temperature, a good heart rate, and now let's see the user that was reported to us. And what comes back is that he's actually too sick for school. So that likely means that we've been compromised somehow. If we look back at our information on the service, and I've made this a little bit easier. I kind of built some scripts to show us what we need. Okay, so we can pull a report then of what are our route rules that we have in place. Traffic for this application is now being routed to version 1 of our app. And this is a policy that's in place. So we can report on this policy. We can see back, yep, all the traffic is flowing to version 1. Okay, so we know who this individual is who's initiating the attack, and we want to block them. And we can block that specific user by working with the header, because we can see that we have a header field that says the user is Ferris. So let's apply that rule. And what that looks like is we have a simple rule here that says if that header has a user of Ferris, then issue a denial. Don't allow that traffic to flow through. And then if we retry the call again, we can see that we put that in the system. So we said for this user, block access, but we still expect that for our other user, for Mary here, this should still work properly. Yeah, and it does. So we have the normal signs back for her. Okay, but then let's look at what we have on the system. That we've identified what the problem is. Our application was using struts, and it was using a version that was out of date. So we can pull back our version info here. Okay, so we have version 1 of the app, and it's running the 2.5.8 release, which was prior to March when that vulnerability was identified. And since then, there's a newer version that has the patch. So we need to be able to deploy that and get it out there quickly. And we have our team that did some work here, and they built version 2 of the app. So if we see kubectl get pods, we should see that we have 2 versions available. We have version 1. At the bottom, we have version 2. Right? And so now we want to take our traffic that had been running with version 1 and we want to deploy it to version 2. So what we'll do here is we'll see what the build information is. And so the way this app works is it looks to see what jar file is in its class path, and it's writing it out to the response here. So we can see that we have this version. Now we want to switch the version that it's routing to version 2. And so for that, we issue a route rule change. We're going to version 2. And if we look at the code here, we've switched over from version 1 to version 2. So we have more, without a downtime, without an incident, we still have traffic flowing between the users and the app. We now have addressed that issue, and we're back to where we want to be. And we still have our rule in place for Ferris, so he's still blocked out. Okay, and there's more to this, so we can talk about that more at the booth if you'd like to. I didn't show the visuals behind it too, but kind of gives you a sense of by introducing that service mesh capability, you can do some controls and get have some capabilities around those services that you wouldn't have otherwise. So if we were trying to reduce risk to our reactive patient vitals app, we know that we want to add some controls here to improve our audit position and to improve our ability to hit a regulatory compliance requirements. We can make use of event sourcing to have that audit trail and that recoverability that covers a few of them. We can have a CQRS in place to make sure that we're writing this data about the patient, that we aren't making that available to everybody else. We're separating the reads of that data, and then we can put more controls around that. If it's patient data, likely has PHI in it, and so we want to control that as much as possible, make that such a narrow thing, and then use identifiers as much as possible versus the data itself. We can create snapshots of the events and then prioritize the ability to replay those. Make that just a part of our system design. So as we're testing, we test the ability to replay events. And as you prove that out, as you make that part of your chaos testing even, that makes it possible for you to feel confident that if the event happened, you could actually recover. We want to minimize instances of sensitive data, so keeping what is sensitive as few instances of that as possible, so we can clean it up if we need to, and just restrict access to it, make sure that it's not flowing when it doesn't need to. And so restricting access, I mentioned that one. Having secure communication between the services. I don't think you really can live in a world where the internal network is considered to be fully secure. That we see too many incidents of people gaining access through the edge and then have full visibility of what's happening internally in the network. So maybe we need to secure the communication between our vital system and the patient, or alerting, establish a mutual TLS there and encrypt that traffic to make sure that it can't be compromised and viewed over the wire. We want to capture and store metrics on who's calling our services, the number of times they're calling it, and the response times that we see. And that becomes a baseline that we can use for our analytics work to see what isn't right. Why all of a sudden did the service that's calling to get the patient data calling 100,000 times more than it normally does in a day? And then last, we can capture the container image, have that version history. So if we need to go back to a time in history where that incident occurred, we can see exactly what code was running and exactly the dependencies that it had in place at the time. Okay, so that's for our app here of the patient vitals. But just more in general, if you're talking to a compliance officer about why you're considering reactive, why this is something that's worth following through on and building an application around, first of all, you want to highlight the business reasons. Right? Usually there's some justification for this. Either you're behind, you're not able to compete with competitors, it's being really difficult for you to actually be able to introduce new features, and highlight those capabilities. That this allows you to address those things. And sometimes it's the business reasons that actually gets the most traction. Highlight the features of the architectural patterns. I mentioned event sourcing, CQRS, recognize what those give you, and then the capabilities of actually implementing them well. Giving real-time visibility to the system, that it happens all the time that something becomes compliant and then it's deployed and then we have no idea what happened to it after that. If you have real-time visibility that yes, we're still meeting the requirements that we said we are, that becomes really powerful. And then auditing. The ability to see that what you had that was compliant is still compliant and is maintaining this compliant stance is something that becomes really powerful. And an example of that, an early example, would be Netflix's security monkey that would go through AWS configurations and feel that, yep, it meets their internal standards. You're going to see more and more of these tools released for that stack that I mentioned with Kubernetes, with Istio, to be able to see that what my policies are that I feel like need to be in place are in place and they haven't been modified. That automation is something that becomes a pretty key aspect of what you can have. And then restricting changes, being able to keep track of who's allowed to make changes to the system, having that traceability that only those people made changes, and then being able to have that reporting and the audit trail of how that was introduced. And then in making improvements on the current targets. If you can reduce your time to patch, so we're seeing that becomes really important, being able to show that we can address this vulnerability not in months, but now in days, in hours, whatever it takes, being able to reduce those targets. And then recovery time objectives, recovery point objectives, so you can reduce those as well. Those become pretty key parts of the story. So with that, wrap up the presentation and ask if anyone has any questions. Yeah, so do speak in the microphone that's there, and we need to turn that on, looks like. Okay, it sounds like it's on.
It's on now? Okay.
Yeah.
So you mentioned there's a proxy that's, I think you said alongside the containers?
Yeah. So
is it, the proxy is not, for instance, built as part of a layer of a Docker container, right? It is inside some VM?
So the container itself, the sidecar container, it is actually a Docker container that Envoy is running as a container, and it's deployed as a sidecar within the pod. So if I show you the number of pods that I showed over here, where you can see there are 2 pods here for this Vitals app, and if you see this sign, there's ready 2 of 2.
Okay.
Those are the 2 containers that are running within that pod. And so before that Envoy was injected into the pod, there was just 1 of 1.
Okay. So quick question then about, we don't use Kubernetes. We're using Habitat from Chef. I don't know if you know that. Do you know off the top of your head how we can integrate with Habitat, or is this something we
so I
have to
haven't
integrate?
seen integration yet. There's going to be more and more of those type of tool integrations coming up, but I haven't heard of that one in particular.
Okay. All right, cool. Thank you.
You mentioned that Istio is not quite production ready.
Yeah.
What are you looking for? What are the specific events that we're still waiting on further testing? What pilot efforts are underway with significant production deployments, et cetera? I'd like some info on the roadmap there.
Yeah, so the first production release of Istio is planned for December. That's where it's going to hit the 0.3 release. And there's a lot of performance testing and tweaking they're doing to hit some of the performance requirements they would need to have in that system that are happening now. That'll make it ready in December. I think then what we're looking at is then how do you better integrate all these pieces of the stack together to provide more of a cohesive deployment and easy to operate a type of system. And we're having some of those conversations with Lightbend too around the Reactive platform of how do we remove areas where maybe there's some duplication today and we can leverage what just exists in the platform. So that work is going on. I think the timeline for that, we've talked about already kind of documenting what a strong, well-built production app would look like and making that easy to deploy. And so I think you'll see that in the ahead. I can't say dates in particular,
But December-ish time frame you mentioned?
So December is when Istio is planned for production readiness. December with the 0.3 release.
And then what are you seeing with regard to the relationship of Istio to Cloud Native Compute Foundation portfolio, Envoy versus Linkerd, stuff like that?
Yeah, so there are two projects that exist in the Cloud Native Compute Foundation. Linkerd is the other one, and then Istio is one there as well. And the CNCF, in general, they're open to having multiple projects that cover the same space. And Service Mesh is what those two are focused on. And so hopefully there's innovation that happens in both. But IBM has been contributing to Istio. I think Buoyant is the team behind Linkerd. But there's room in the landscape for both.
You're saying they're viewed almost as alternatives for similar
Yeah,
functions.
they're all alternatives, and that's fine, whatever fits the use case. What Istio, I think, is focused on is more of a broader set of runtimes, and then having asynchronous be part of what's supported in the calls as well. Whereas I don't know that in particular for Linkerd, but I think there's a more narrow focus on what they have there.
Thank you.
Okay, with that, enjoy lunch. Thanks.